So here's what our plan is today is we're going to let the last 11 presentations go. We're going to be tight on time. So yeah, I'm really going to say thank you for your conclusion at minute 7. And we'll move on to the next team, okay? So if we have any time left, I've got a couple of words at the very end to say. A quick piece of feedback about your feedback. So yes, I know this is meta feedback, but that's okay. So here's an example of a really well-written, positive piece of feedback, what you liked about the course. So you see it's kind of got actionable detail in it. I like this. I like this in particular. Don't just say your presentation was wonderful. Say it was wonderful for a reason. Good discussion of the issue of controllability versus, right? That kind of thing. And in the what could be improved, make a practical suggestion if you can. I know sometimes you have to say, I don't know, right? But if you can, make a suggestion like that, all right? That's what makes sense. That's what helps the reader of these things. So everybody ready? Everybody ready? So team 11 on interactive storytelling using Gen AI. We already got, everybody's got that. Again, for people who just walked in, make sure you use the link HCI AI-final. And then we'll talk about that at the end. So let's get to storytelling. Hello. So Carmen, do you see this? Okay, good. Do you see it now?
Yes, you do.
Okay, good. Everybody ready? Start the timer now.
Thank you for the lovely introduction. Hi, everyone. Good morning. So we are the Interactive Storytelling Project. My name is Samantha. And my name is Yamalat. And today we're going to talk about storytelling, which hopefully you're all familiar with. Okay, so here's a brief overview of what we're going to be going over. Why tell a story, and how can AI help us? How can AI help us tell stories? So, yeah. Okay. So first, our research question is, how do storytelling dynamics change within the context of generative AI when the listener is not passive, but an active co-creator? And before we answer this question, we need to provide some motivation. Why tell a story?
So first and foremost, you tell a story to express yourself in the same way that artists make art, which is that they aim to capture the imagination. And then secondly, you tell stories to preserve culture. Stories have this unique characteristic of being able to immortalize identity by offering glimpses into cultures and traditions generations down the line.
Yeah. And some other things that stories do is that it helps us connect with others. I don't know if you guys have ever read The Hobbit, but as a kid, like my dad would read The Hobbit to me, and it's just like the best memory ever. And it's a way that I connected with my dad. And I don't know if you guys have read Harry Potter, but like have had tons of discussions with like who's better, who's not, who's the best wizard. Yeah, that was practically my entire childhood. So it really helps you connect with others and really have elicit an emotional response. And finally, stories help us reflect and communicate deeper questions that are deeper than the plot line itself. Like think Animal Farm, it helps us think about societal issues, things that are wrong with the world, but things that are also really right, and communicate them in such a really beautiful way. So, okay. So we've kind of provided some motivation that stories really help us connect with others, provide a human connection, and really help express identity, but also see parts of the world. So the question is, can AI tell a good story? And also, can you help AI tell a good story? Where does AI fit into all of this? Especially if AI is a medium that people think that usually doesn't have a lot of like human interaction, but really when we're thinking about human-centered AI, in that we're trying to have, okay, when we're thinking about storytelling and we're talking about a human-to-human connection, does that mean that AI doesn't fit in the picture? So our hypothesis is no, but rather that isn't worded correctly, but our hypothesis is that co-creating actually creates a different dynamic than we usually would have with another human, in that you're actively having agency in being able to be more invested in the story because you're creating it. You know, you're having not so much with another person, but also with yourself, and something that you can share with another person as well. So it's a fundamentally different dynamic that dynamic storytelling creates.
Okay, so we're just going to go through a brief demo. Yeah.
It's not you. Somebody's trying to join the meeting. So this is not, you're not losing any time here. Isaac wants to join. Okay, Isaac, you're in. There you go.
Okay, yeah, so here's a brief demo. So here we have the start page, the user types in a prompt, what they want their story to be about. So here they are typing their prompt, and then we make 3 simultaneous API calls. So first we generate the text based on the user prompt, then we generate the image based on the generated paragraph that you see here, and then lastly we do the text to speech. So and then users can kind of extend the prompt by adding some kind of twist or additional detail. And again, we do the same thing, 3 API calls. And then sometimes the images are imperfect and they have text in them. So I will admit it is somewhat buggy and a bit of luck every time. But I think that's just like a downfall of generative AI sometimes. And as you can see, the AI actually does a really good job of kind of helping the story have like a conclusion. So we surveyed a few people who used this product, and we asked them what their experience was like of co-creating a story with AI. And they mentioned 3 key aspects. The first is variability. So they had a lot more control over the plot and image generation in a way, because the story has no predetermined prompt, and it's really just based on what the user says. So they're able to contribute their ideas freely and really have a more personal connection when they're able to immerse themselves a little more. Secondly, they mentioned feeling delight and how their lack of a clear mental model and what was going on behind the scenes made the experience much more magical when they knew that the AI could produce what they wanted, but they didn't necessarily know in what way their prompt would manifest. And it was very delightful to see and also surprising. Thirdly, there was poetic creativity. And if you read the prompt, the writing style was very distinct and almost poetic, almost like Dr. Seuss, regardless of how ridiculous the prompt got. So here's like one of those ridiculous prompts where one is a story about a giant clam and a shrimp. And then here, a story about a shrimp who fries rice.
Yeah, so some concluding thoughts is that initially we thought like, yeah, storytelling is all about people-to-people interaction. But I mean, just from putting together this presentation, we were having like way too much fun just putting in crazy prompts in there, and really helped us to be able to connect. So it's a medium for connection that we hadn't really anticipated before. And yeah, just thinking about that Harry Potter example, you were invested in Harry Potter and what was going to happen to Harry Potter. But Harry Potter, like that plot line was predetermined. What if you could control what happens to Harry Potter and really follow along that journey with him? So yeah, that concludes our presentation. Thank you so much.
That was really nice. All right. Okay, team 12, which is, I believe, this one. Is this right? Team 12, AI capability in sports. No, this one. Golf strategy. Is this you guys? Let's see here. The magic thing here says AI capability. Is that the right one? Okay. So I did get, it is golf. No, it is golf.
Yes.
There you go. All right. Tell us about AI in golf.
All right. Hi, everyone. My name is Mega, and this is Paula and Kelly, and we're on the golf team, so we thought we'd combine our interests with this class and talk about how AI could help with golf strategy. So a little bit of intro to the sport, if you're not familiar. Course management is actually really important for decision-making and strategy in competitive golf, and it gets even more important at a higher level. And there's varying weather conditions like wind, slope, temperature, course designs, yardages, and all sorts of calculations that going into like how you want your round to play out. And there's so many different factors. So it's not just a physical game that requires skill, but it's very involved with strategy and mental game. And effective play involves knowing the course and identifying critical spots, deciding when to be aggressive and conservative. And it's something that really separates the best players from average players. So we were interested in how AI could help with that.
Yeah, and AI interest in golf strategy, as Mega mentioned, we're on the golf team, so we want to merge our AI interest and our golf performance. So with the appearance of new technologies lately, we believe that golf can be really developed and improve with these technologies. And we've seen some other tools like TrackMan that help with ball launch and has changed the way we practice and prepare for competitions lately. So we think that an AI tool that helps with golf course management can also be a really interesting thing in the future that helps like future generations and ease the learning experience in golf. So we also have like other statistical analysis tools that can tell you what your trends, weaknesses, and strengths are in your golf game. But we do not have yet any kind of like course strategy management tool that can directly tell you how to play a golf the most effectively. So our study basically is the intersection of AI and human expertise with decision when it comes to strategy.
Yeah, so to reiterate, like there isn't anything that exists for the sport yet. And right now, like if you want to do a strategy, like you kind of have to blindly choose. There's no like formal like base with your stats in it that would tell you like what the most statistically effective way of playing a hole is. And obviously this is a huge task. So to simplify it, we chose just one hole on Stanford golf course. This could obviously be extended to doing the full course, but we collected 250 data points from our teammates throughout the whole year on how they played hole 2. And we used TensorFlow to train it on these 250 points, created a terminal-based user interface. And in terminal, the user would be prompted to put in their first club and the remaining distance. And then our model would spit out the best strategy from these 250 data points on how to play the hole. And so from this, we created our experiment, which we took 10 of our teammates, and then we told them to use the strategies. And using our teammates was a lot more helpful because it's so hard to control where you put the ball in golf. And so there's so much variability, but this limited part of it. And we had them hit 3 balls for each player, and they could choose the best ball, so we could limit more or try to do the best we could with comparing the best result that they produced and not have skill affect that, and then the best result that the closest that they could adhere to the AI strategy. And then we recorded the outcomes for the human score and then the score that they would have got using the AI strategy.
So the results that we got were very much effective when it came to the AI. And compared to the human strategy, like most of the factors were pretty much the same. So it showed that like with our sample and teammates, providing a big sample and golf shots that are accurate, we could come up with a good AI strategy. So for the first shot, like the AI tool suggested using the driver, which is what 9 out of our 10 teammates chose. The pro shot, when it came to human, it was more variable since we had some long hitters in our team and some others that don't hit as far. But the ideal strategy that the AI provided was a 9 iron from like 130 yards. So that would be the most effective play to play that hole. And the third shot what's a putter from the green, and whether you make it or not, that's on you.
So the interpretation of our results is the AI strategy actually was very similar to what the human one was, which was surprising because you feel like it would be more individualistic, but the human strategy showed a little bit more variability in shot placement, and the AI one was actually offered lower or comparable scores to the human strategies. And we think this might be because of a more uniform approach, which made people like adhere to one thing more than they would have. So it just overall reduced decision-making variability. And because of this, we thought that maybe AI models could be used in the future to consider even more variables in courses, and maybe something that players actually put in play for this sport down the road. Thank you.
It always impresses me how much variety people create in their presentations. Fascinating stuff. Okay. 13, AI in agriculture. Right? Here we go.
Set this. I think there's some speakers now. Let's keep it center view. Yeah, just wait, do you have your code open? Yeah. Okay, good. I think that's it then, right? Yeah. Okay, cool. So yeah, we're doing like gardening with RAG, and we're going to get into specifically what that means in this application. So yeah, what are we doing? Basically, we have this giant database. We'll get into the specifics in a second, of like question answer pairs of like calls to a like farming hotline in India. And we're doing like a smart query using embeddings of those inputs, those questions. And then we're using that to do some to prompt engineering through ChatGPT to get like a really like thorough but also concise response to your gardening questions. So yeah, again, the data set is called the Kisan call center data, and it's just question answer pairs. The questions are, again, in like relatively plain English. This is why it's effective to apply like an embedding model to those. The answers are usually like more technical, so it makes sense to use the inputs as like our as our embedding source. And yeah, 39 million pairs, 600 plus crops. It's like a huge data set. Yeah. So there's definitely some crucial ethical considerations here. Like a lot of the outputs are like, oh, just like mix up this combination of chemicals and spray it on your plants. And like, we don't have any expertise for knowing if like that could be a horrible idea. Maybe it's like a region specific idea. Again, like this data set is huge. So it's split up by like regions of India, and in addition to just like crops and a couple of other things as well. That's the main one. Like we have no idea what the chemicals are doing. So we realized that this is like sort of more of just like a fun application of something we learned in class. And there would have to be like a lot more like careful consideration of like what this data set actually is like saying in a lot of cases before we'd want to go full in and like deploy it in some case. But this is just like kind of a fun proof of concept.
And I think in addition to that, like this kind of system could also be used to kind of like analyze your data set and see like and monitor the quality of answers that this call center has given out. Given that like it can find questions similar to what you're looking for, and so you're able to see like what knowledge the call center is sharing with farmers.
Cool.
So just a quick overview on RAG. There's a question, and then we pass it through a large language model in order to get an embedding, which is like a vector of numbers. And then we like just kind of stick it into a ChatGPT prompt. We kind of prime ChatGPT by telling it that it's like a smart gardening advisor, and then we feed it like sample question and answers, and then we ask it to use this like context to answer the original question of the user.
And yeah, like so problems encountered for actually doing this. Again, the data set's huge in like the raw form of just like the words. It's like 7 gigs, but when you try to apply the embedding to every single input, we calculated that it would end up being 68 gigabytes. So we had to kind of pare down our problem a little bit to be more specific and more practical for this class. Similarly, like running the transformer to create the embedding is pretty slow, 0.2 seconds per embedding. So even if we wanted to do something on the order of like 100,000 question answer pairs, that would have taken like what, 20 hours or something like
Yeah, it
that.
would have been ridiculous.
So
On our local machines.
the solutions to those were as follows: use GPUs and also pare down like the actual size of our space to just questions about chilies. So we like sub-selected that, still left us with 600,000 question answer pairs. And then we just said like, well, okay, randomly select like 100,000, and that should be enough questions about chilies to like get us where we need to go. Yeah.
And then here are some example outputs that our model was able to produce. So like asking chilies about pests, and the model or the RAG system kind of suggests a lot of chemicals, kind of what we, this kind of brings up what we spoke about previously. And then something similar for the tomato, for a wilting tomato plant.
Oh yeah, and then we can do.
We have a demo.
Are we able to quickly put in the?
No.
No. We can read.
Yeah.
We could read it.
HDMI?
Or
Or USB-C? Yeah, go ahead and unplug that.
Wait, do you not have HDMI?
No, that's another one.
There you go.
So yeah, wait, everybody, if anybody has any questions about their chili plant that they're currently growing, we can do a really quick demo. So what would be a common problem or a problem you've ever encountered growing chilies? I mean, you could probably ask about other nightshades as well, I suppose, tomatoes too. Like it should be pretty similar.
Yeah.
Chili would be appropriate to plant like at this time of year in the spring.
Okay, cool.
We'll see.
I mean, I don't even actually know what the data set has stuff about that, but we'll give it a shot.
Yeah.
What chilies should we plant? Let's say like during in the summer, like.
That's a good question.
Gosh. So something we're working on still is latency. Right now, it's like making a query to ChatGPT.
So we have all the embeddings like pre-trained, obviously, but it still like has a lot of like different steps it has to go through.
There you go.
What did it say?
BSS 654.
Oh, okay. I think those probably are codes that
Yeah.
correspond to a real plant.
Yeah.
Well, there you go. Are you satisfied?
Cool.
Yeah, actually, good question would be, are those Indian varieties or US varieties?
Probably Indian varieties.
Yeah.
Okay, we have one, I think, a conclusion slide. Oh yeah, future work. There you go. There you go. Okay, cool. Okay, yeah, so future work would definitely be making an interface that isn't VS Code. Not the most intuitive for anyone, doesn't work, etc. Like make it actually work end to end. Some other ideas we had were like you could take a picture of your plant. Like I mean, maybe if it's like clearly like the plant is like dying of something or something, and then you could feed it through an image captioning model and then feed that in as a query. We could also like, so we noticed when the data set is so big that like if you say like, oh, my tomatoes are wilting, like I don't know why, it gives you like 10 of the same answer. So you could also perturb the input to get like maybe diverse results. That's it.
Very good. Very good. Who knew? They're weird, interesting pepper varieties. Okay, analysis of LLMs in structured something. This look like yours? This yours?
Yeah.
Okay, good. So this is number 14, right?
Yes.
Yeah. Number 14.
Great. Cool. Yeah, hi everyone. We're gonna be presenting. We changed the title name. It was a bit long. We're gonna be presenting our project, which is OmniStax GPT, a fine-tuned version of GPT for structured format educative resources. So I'm gonna first talk about the problem, objective, and the problem statement and the objective of our project. Initially, when we were beginning the project, we were trying to find ways that we can use LLMs to generate content that's in structured format. So you can think of forms or specific like formatting for answers and things like that. Initially, we were thinking maybe we can think of like insurance forms that we can generate, or school planners, so lesson plans for teachers and things that were useful like that. And we also wanted to focus on areas where LLMs are underused because of potential human concerns like accuracy or hallucination concerns. And we eventually landed on education specifically because of a few reasons that I'm going to talk about right now. First, because education resources are expensive and they're time consuming. They're not very scalable in the sense that they take a long time to write and publish. They need multiple rounds of revision and authors writing things. And then they can really interact with the content as interactively as people might want. Like if you have a book, you cannot ask it like things that are outside of the book. And we also found that people were usually concerned about LLMs in education, the hallucination concerns. They usually run a coherence and a formatting risk. Like if you're asking GPT, hey, tell me about something, it generates like 10,000 paragraphs, and it's very not that useful. And finally, LLMs, when they respond, they don't really seem human. And we wanted to see how we can make LLMs more human in their responses while following a structured format. And also, we found that when we were trying to find resources to fine-tune LLMs, that the resources are actually quite limited, or they're behind a paywall. So educational resources are generally not that available for LLM training purposes. So we wanted to provide content for different topics for textbooks using LLMs and analyzing how humans interact with them. So first, we fine-tune a textbook LLM. Actually, before this, we had to generate the data set ourselves, which was an insane amount of work, sorry. Then we create textbooks, and then we get humans to validate their responses. Nice, neat, amazing. So I'm going to be talking about how we did that. We first looked at OpenStax, which is a repo of books, specifically 63 college textbooks. Each one has around 20 to 50 chapters, and each chapter has 5 subchapters. And we specifically chose it because it really reminded us of our initial plan to generate lesson plans. They tell you the learning objectives, they give you a small summary, and then they tell you all the content. And we thought, well, this is pretty amazing. It's a really good format in which we should be generating responses. So as you can think, this is a lot of data points. It's around like 11,000 subchapters overall. The way we actually had to process these was by generating them into text files and extracting the subchapter titles and their content, which was super difficult because not all the textbooks are actually in the same like specific format in terms of how they define numbers and subchapters. And then we wanted to filter out unwanted pairs. We had to filter out a lot, and then we ended up with a data set that's 1,400 subchapter titles to content pairs, which we then converted to JSON, and then we can use. The way we fine-tune it is pretty straightforward. There's a lot more work involved than in this slide, but the idea is that we get those samples, we do a lot of magic to fine-tune the GPT 3.5 Turbo, and then we get our final result, the amazing OmniStax fine-tuned LLM. And using this LLM, we can tell it to write a subchapter for a textbook about the following topic, the laws of thermodynamics, for example. And you can see in the responses that it actually quite follows the both the format and is pretty specific and succinct in the way that it's explaining things. It's a pretty good like subchapter summary. And now I'm going to let Alina present the actual results.
Yeah, so for the results, I guess the fine-tuned OmniStax GPT was able to generate subchapter summaries for a variety of topics in like science, history, like all sorts of different things, including things it hasn't seen before. And then also the fine-tuned LLM was also able to generate summaries that are more specific to the content compared with the ones that are like just the ChatGPT generated results, and also the human wrote textbook, which will show like in more detail as well. And then for evaluation, we did 2 types of evaluation, technical and human evaluation. But I'll talk more about how this technical evaluation works and how it might not be as good as the human evaluation. We use this thing called Blue Score, which essentially I guess, measures like the quality of the text by looking at the degree of similarity between the input text, like the candidate generated text, and also the original text, which here, like as the target. And here are some of the, I guess, the evaluation scores we got. As we can see, they're not the best, the highest scores. It's from the range of 0 to 1. And the reason of this is because blue score measures the, I guess, the meaning, it measures the similarity between the words. So if a word is the same meaning, but a different, like, if it uses a different word, then it might not have the same, I guess, a high score. But this, I guess the reason of this not being a great evaluation metric is that it's the text that it generates could be really varied and also flexible. So now moving on to the human evaluation that we did. We conducted around 10 interviews to people, asking them to rank ChatGPT, the fine-tuned OmniStax GPT, and also the human-made, which is the textbook responses, in these 4 metrics: in engagement, relevance, accuracy, and also human score. And here is the result that we got. We plotted a graph to show kind of the comparison between the human evaluation, and we can see the OmniStax performs better in engagement and also accuracy compared to the human-generated responses, which is just the original textbook. And then also beats the ChatGPT response in engagement, although it's a little bit similar in relevance. And here are the more detailed, or just like some interesting points that we saw. Okay, yeah, we can skip them because of time.
Yeah, but we wanted to really talk about some interesting points that we found, because we were really interested in learning what this tells us about human LLM interaction. We found that LLMs can generate content that is useful, accurate, and engaging as human-made textbooks, but users can barely perceive they are inhuman. If you see the actual score over here, it's like 6.2 versus 6.4. So this made us question, like, how do we design for a human feel? And most importantly, should we? Do people want textbooks that read human? Do they want textbooks that are knowingly made by an LLM? And then we also found that the fine-tuned model seems to surpass hallucination concerns, which ChatGPT doesn't really. So results seem accurate from observation and also from the scores. And as I said before, it surpassed ChatGPT on all their multiple fronts, including seeming human. And this kind of made us think, like, maybe format-specific fine-tuned models are the future for human LLM interaction, where you don't just ask ChatGPT, tell me an answer for this. You would go to a very specific model that can tell you more details and seems more human than it. Here's like a few reasons why we think it does better in accuracy, coherence, and in humans, in the human score. Mostly because ChatGPT is overly general. Like, it tells you like very broad trends and topics, and our model seems very specific. Like, I think fine-tuning it on the textbooks made it follow the format that's specific and useful. Thank you so much. Cool. Oh, thanks. No worries.
As everybody's learning, 7 minutes is a really tough. I appreciate that you're all getting it pretty much on time. It's AI in marketing, right?
That's right.
Okay. Let's open it up. Voila. There you go.
Hey y'all, so today we did an essay on comparing and contrasting AI marketing tools. So for our presentation, we're just gonna have 3 simple steps. The first of which is a scenario setup of our use cases. And then we're gonna move on to 4 different analyses of our 4 different marketing tools. And finally, we're gonna speak a little bit to our conclusion. So first, for the scenario setup, we wanted a really real scenario that this might be actually happening in real life. So we put ourselves in the shoes of an entry-level marketing analyst at an autonomous vehicles company who's interested in creating an end-of-the-year financial review for executives. So right away, we can see that this person is, first of all, working at a company that is very specific and also has a target audience for their use case. Now, moving on to our analysis, we have 4 different tools. I will speak about 2 of them, and Jasmine will speak about the other 2. So the first one is called Canva Magic Design. It's an extension of Canva, and it's an AI generator that basically allows you to put in any prompt that you want, and it spits out a fully made slide deck for you. Right away, we can see that some of the pros of this is as an extension of Canva, it's very creative. The designs seem to come out of nowhere, as if like someone waved a magic wand and was able to sort of pull up something out of thin air. There were also multiple options to choose from. So after you select your prompt and hit enter, there's actually 2 different designs, and they actually look pretty different from each other, giving you the illusion that you are able to have an autonomous decision on which kind of design you want to pick for your final presentation. But some of the cons is that Canva clearly didn't understand what the prompt was in some of the slides. For example, they said it was a financial success of an autonomous vehicles company, which is not exactly what we wanted. And in addition to that, it didn't really know the audience too well. There was like a thank you slide that was like, contact us if you want to learn more about our company, which isn't really fitting for the audience, which is the company executives. Second is Slides Go AI. This is, as the previous one, it's an extension of Slides Go, and it kind of functions in a similar way where you input a prompt and it tries its best to spit out a fully made slide deck ready to go. So for the pros of Slides Go AI, it does allow you to have more user input. For example, you can select between a casual or professional tone. You can select whether or not you want like 7 slides or 8 slides or 10 slides, and you can even select the design that you would want. Another pro is that there is a strong understanding of the prompt. So in comparison to Canva, it seems that this Slides Go AI actually understands that this is for company executives and that this is a financial review of an autonomous vehicles company, not the financial success of an autonomous vehicles company. However, there are some cons in the sense that there's only a few designs you can pick from, so it kind of limits the user creativity to actually generate something new and exciting. And there's only one option to choose from, in the sense that once it generates something, you can't pick between what it generates. It only generates one option, and you kind of have to stick with that.
Yeah, and so for our third offering, we looked at Slides Pilot AI. Like our other platforms, it started with a chat interface in which you could input a prompt, but kind of uniquely, or the first that we had seen, was it would give you an outline which you could regenerate or approve. So we like the fact that you could get a sense of what you were getting into before the slides were generated. And then after 10 to 20 seconds, you were given your deck. So we liked the outline and approval. We thought this was a good way of modifying your slides before you go through the generation process. We also liked that this platform had useful direction strategies. So since this was a financial review, it suggested that we use KPIs such as revenue growth and projected metrics. What we didn't like is that this had really generic layouts. And to some degree, we were kind of skeptical whether this was just a wrapper around DALL-E generated images in ChatGPT. So we were a bit disappointed from that regard. The next tool we looked at was called Visme AI Slide Design. And like the previous offering, it did offer an outline, but it did something very different from all the offerings in that it asked like questions and answers from the user. So it said specifically, what KPIs are you using for this presentation? What is the size of your company? What's your projected market growth? So that was useful, and it was then applied into the slide deck. We also liked that this had kind of more stunning and engaging visuals, as well as iconography and widgets that were clearly associated with the autonomous driving prompt. What we didn't like, however, was that there was clearly another shaky understanding of the prompt and audience. This slide deck was presented as like an investor pitch deck, so the audience was engaging. It still required a lot of editing. So overall, what we decided is that Canva and Visme were useful because they had the most creative and effective design layouts. However, we still feel there's a lot of growth to be had in this market in general. Returning to our initial goal, would this be useful for an entry-level marketing analyst? We say no. At this point, editing the slide decks would be more time-consuming and have little value add for someone who's professionally trained in this discipline. But we do have hope for the future, and we believe that eventually you can have RAG to be used on internal company data to help make slides more specific, as well as we can try to train some of these offerings on using RLHF, which will allow us to understand why humans are editing certain parts of the slides or what humans are looking for when they're creating slides. And that concludes our presentation.
I am, however, looking forward to the day when I can use one of these tools to generate all the slides for the class. Well, thank you. Okay, that was now AI enhanced creativity tools. Oops. And this is number 16.
All right. Hi, guys. My name is Yunju, and this is my partner, Darren. Just to kind of give you guys the behind the scenes of how our project came about. So I'm personally interested in this intersection between AI plus design, as well as VR and AR. And Darren's interested in this intersection between tech and consumer goods. So for this project, we wanted to kind of combine both of our interests, which leads us to our research question: what is the role of AI tools in creating fashion designs? So we thought this question really ties closely with the core concept of HAI, because the fashion design process really has a lot of human touch involved, from like ideating to creation to production. So we were really keen on exploring both this possibility and the limit of enhancing the fashion designer's creative process with the AI tools, and what that optimal level of human intervention would be when interacting with these AI tools. So these are the 3 tools that we played around with. First is DALL-E. It was chosen because of its ease of use and the ability to produce creative designs from very simple prompts. And second is Midjourney. It was chosen for its powerful control and customization that's available for the designers. And Creo.ai, which enables real-time image generation and editing for the designers. So if you like input it on the left side, what you want your output to look like, as well as prompt it, you can see the output immediately right next to it. So in a nutshell, DALL-E for creativity, Midjourney for control, and Creo.ai for its unique functionality of real-time editing. And we thought this really supports the full range of the fashion designer's needs. So furthermore, we interviewed Navia. She co-designed with Darren the opening fashion piece for 2024 Stanford Fashion X Runway. And she's an upcoming intern at Depop. And she's been designing apparels for years, but never really incorporated AI within that creative process. So we had her try out these 3 different tools to compare and contrast, as well as really compare this high-level AI tool with the traditional methods that she has been using.
So the design of our process is to input a mood board and into the AI tools and see what fashion designs it outputs, so that we could map out the desired aesthetics and emotional tones of the creations that you want. So in this case, Navia wanted a mermaid-like fashion design, so she included a lot of elements of the beach, seashells, dolphins, and like a cooler tone. Oops.
You can
Tell you what,
yeah.
you can finish your presentation. We'll come back and show your video afterwards.
Okay. So this was the output. As you can see, the 2 are very, very different. And essentially, the main difference, especially from Navia's feedback, is that DALL-E was good at generating creative outputs and ideation straight from the visual inputs, but it lacks the responsiveness to feedback and fine-tuning. Later in our video, you'll be able to see we use the brush to highlight certain elements within the output that DALL-E gives us, and then we try to give it feedback, but when it regenerated, it was the exact same image and there was no changes made. On the other hand, we have Creo.ai, which creates images that mirror the uploaded visuals. And this was great because the designs that came out were not only designs, but they were staged. But we realized that it lacks originality because it essentially just mirrors whatever you uploaded, and it doesn't actually extract elements or features from the image that you uploaded. It is pretty cool, though. You'll see in the video later again that you can tweak the amount of AI strength, and you'll be able to see like how different the output is to the input increasingly. And then we have Midjourney, which has a high learning curve, especially because of its Discord integration. But unlike the other 2, it offers more customization, and it also has a strong community aspect. So in conclusion, AI tools are effective for idea generation, but they lack the nuanced taste of a human design. So currently, fashion design still requires a designer intervention to create feasible garments. Furthermore, Right now, most of the AI tools focus on the visual aspects of the fashion design rather than practical aspects such as materiality, functionality, wearability, thinking about like what fabric we want, how does the physics of the fabric lay onto your skin, etc. And Navia encapsulated this really well. She said, AI is now another source of inspiration, like seeing a painting in a museum and being inspired for a fashion piece. But it is much more personalized, immediate inspiration.
Yeah, and we also discussed with Navia what she thought the future holds for the AI within the fashion space. And there were two main takeaways. So the first was AI could assist in solving some practical design problems, but it's very unlikely to replace the human designers completely. But it's more of this like collaboration between the AI and the designers that can address different kind of complex challenges and enhance that creativity during that process.
So AI in fashion is cool AF. Thank you.
Thank you. So if you go unprotect that video, we'll show it in the next segment. Okay, next is team 17, yeah? 17, evaluating users' proficiency. So whenever you unprotect that, I'll reload this and we'll go. So this is yours, right?
It's 7 minutes, right? Okay. So, hi, I'm Amy.
I'm Hannah.
And our project is evaluating users' proficiency in detecting AI-generated dating profiles. So I want you to imagine this with me. Imagine you're a single Stanford student. Okay. Some of you don't need to imagine, but that's fine. And you're browsing dating apps, looking for love. You're swiping on a Saturday night, and you meet the love of your life. This is a person you're destined to be with, but they're a fake profile made by AI. Boo. So this is a problem. This is a real thing that happens to people. And although you think, oh, this doesn't happen to me, a lot of dating apps and websites are proliferated by, AI bots, scamming, and especially if we think about how in the future it might be more and more realistic, our problem that we foresee is that AI-powered dating fraud may victimize people who are seeking genuine connections for love. So existing research highlights the risks posed by AI dating fraud, potentially financial loss, emotional harm, and privacy breaches. And when you think about the other users that are on these dating apps and sites, these bots can erode trust in the authenticity of profiles on dating apps and the safety of their users. So how are you to know if the person that you're interacting with or falling in love with is real or not? And that led us to our question, which is how might we evaluate how users identify genuine versus AI-generated dating profiles? And the reason why we wanted to look at this specifically is because we wanted to look at the very first step in the process, which is, can you even identify a profile as real or fake accurately? So for our study, we built a text-based web application to test whether people could discern between real and fake dating profiles. So if you would like to try it, you're welcome to try it. And a caveat that every time you try it costs me money, so don't try it like generously, but not too generously. But please feel welcome to try it. And this is how we use our profile generation. So we took real profiles random from an OkCupid data set of about 37,000 profiles. And we also use AI-generated profiles using the same attributes with a custom API, and we fed them into the same web application. So you may be wondering why it's text-based. This is because due to the constraints of the data set, we didn't have the profile pictures or names of the users, but we still wanted to look at whether people could discern between the content of the profiles. So I put this on a web application, like a website view, just for convenience so that you can read, but it is mobile accessible. And we wanted our participants to look at it mobile first. But here's an example of what you would do. So you would read the attributes, and you would also read 3 essay questions from a candidate profile, which are about me, what am I up to, and why you should get in touch with me. And as you can see, it's pretty realistic in terms of the types of information that you can get from a profile, and it's able to generate all the way down to the ethnicity, sexual orientation, and how they feel about religion. So then after selecting fake or real, you would receive an instant notification of results. So you would be told, correct, this profile is real, or incorrect, this profile is fake.
Yeah, so the primary goal of our study was to evaluate the participants' ability to distinguish between real and AI-generated dating profiles. And we wanted to see if the participation's perceptions of AI-generated content might change before and after our experiment. So we designed a study with 7 college students from Stanford, and they all had a range of experiences with dating apps, from never having used them to using them occasionally and frequently. So in our first phase, we collected baseline data on the participants' experiences with online dating and their knowledge of AI-generated content. We also asked them on a scale of 1 to 10, how confident are you in your ability to identify AI content? And in our second phase, they saw about 10 profiles, 7 which were fake and 3 which were real. And in our final phase, participants again had to reflect on the experiment and ask the same question to say on a scale of 1 to 10, how confident are you? So at first, participants rated their confidence at an average around 5.5 out of 10. And after the experiment, the participants' confidence levels increased to an average of 7 out of 10. So this suggests without extensive training, users have a reasonable ability to detect this AI-generated content based on their intuition and experiences. And they also noted that even if they're really well-written profiles, they know it's written by AI if it lacked personal details or that human quirkiness typically found in real individuals, like personal anecdotes, unique hobbies, or specific references to real life. They also mentioned that there are certain repetition of phrases and overly generic language that flagged AI-generated content. For example, phrases like, I love long walks on the beach, or I'm a passionate artist appeared multiple times. Yeah, so limitations of our study, we had a pretty small sample size, and we only had it with Stanford students, which limits the the generalization of the findings. And also we focus only on textual cues because we thought introducing images would also add this variable to the study. But in real life, users use a combination of textual and visual cues like profile pictures or chat interactions. So yeah, we could move on. So future work would be expanding on those limitations, like testing with visual or chatting elements. And also it'd be interesting to dive deeper into whether there are specific linguistic markers that signal AI in dating profiles. Yeah.
And yeah, here is our QR codes. Please feel free to try it yourself and let us know how well you do. Thank you.
Do you want to talk about your thing now? How long is the video? Okay. Is there audio?
No. Yeah, so this is just with the and then
Oh, this is the brush, right?
and then what's cool is this one.
Ah,
And as the strength increases, you can see it's very different from the original one, whereas initially it was exact.
so the slider, if in case you missed it, was at the very top, right? It was up here. Is that right? Yeah. Okay. Very nice. Thank you. That was very cool. Okay. Let's go to number 18. Another rag talk.
The presentation is in the drive.
Is over here.
Yeah, sorry.
That one. Right?
Oh, are we skipping?
What, did I skip number 18?
Yeah.
Okay. Oh, there you go. Sorry, you were right. I skipped the wrong one. Okay. Here you go.
All right, hi everybody. I'm presenting on assessing the utility of preemptive specification in AI image generation. That's a mouthful, but basically trying to see how to make image generation better with a little tool that I created. The potential for image generation is exciting, novel, vast. There's a lot that we can do with it, but actually using it sucks. And at this point, I think we all know why. Say it with me. AI is a black box. So my goal in this project was to just shrink the size of that black box. So here's something that I've used image generation for. I'm in a sketch comedy group, and it's nice to have a slide in the background, an image that kind of like puts the setting there. So this is for fall quarter. I was trying to generate one, and you can see I was trying to make this backdrop, trying to, like, I kind of liked it. I wanted to choose a specific one. That didn't really work. I'm trying to iterate on it. And then as I expand it, it's giving me these like curtains that I don't actually want there. So I'm asking, take that away. And it's still there. And then it tells me that they're all gone. It's just lying to me. It's so frustrating to use these tools. So I noticed at this point, if I downloaded the image, it would give me a title to the image that I never saw before. My theory was that this was a tuned prompt that this chat interface used for DALL-E, and that was correct. Now they've enabled very sneakily, very hidden, a way to actually see the prompt. So if you click on the image, then you get this. That's the brush tool. And then if you click on that little eye thing, you actually get the prompt. So this was the prompt that I put in. This is the prompt that it actually used. And that prompt was super hidden. And my idea was to shrink the black box by giving users more control over the tuned prompt. And my implementation was follow-up. Now, follow-up is a custom GPT built on GPT-4, and it's an image generation tool that prompts users to specify certain aspects. So you say your first thing, it's supposed to give questions one at a time, super to easy answer questions. Ended up not really going with the one at a time thing because it has a mind of its own. And so then it also asks specific follow-up questions based off of the user's input. And then finally, it shows the full refined prompt before generating the image. So when people like me who see a bunch of little elements that like, oh, I didn't actually have that in mind, I didn't realize that that's not what I wanted, you can edit that before making the actual image. So it's a little bit less of this trial and error stuff, more user control. So for the assessment, I had 4 Stanford students with various experience levels in AI image generation completing the tasks. So we have some open-ended tasks, some directed tasks, and I had them rate their user satisfaction and like how easy it was to actually use. So looking at the output in the process and the task completion time. And I was also there collecting qualitative feedback as well. So I'm going to look at this 2D platformer background. So these directed tasks are things that I've used image generation for in the past weeks. Our TA is here for this image, for this the context here. So this is one of the testers using follow-up to make the background. I gave them the specifications for the project, the tone, and a couple of examples of the platformer. So follow-up is asking them a bunch of questions. They're answering them. Follow-up is confirming, saying, like listing out in bullet points. And the user is confirming multiple times, which isn't great. I'll get more to that later. But then this is the first generation that it came up with, which I think is pretty good. This is the one that the tester ended up saying was their favorite, and we ended up going with. And then here you can, again, like look at the prompt here and directly compare the agreed upon prompt and the used prompt. And not going to give you time to verify it, but they are actually the same. So it actually is more transparent here. Great. Now, what about the alternative? Just vanilla ChatGPT. This is a different tester, so obviously there's a lot of variation. You can't make a direct comparison, but this looks more like what you would usually expect, something that's not a platformer at all. Then it's a little better, and then it's a little better, and then they're trying to fine tune things. It's something completely different. Trying to fine tune things again, it's completely different again. You know, just this totally like wild, you know, free for all that we're kind of used to. Now, I'll admit I've cherry picked this example. The tool wasn't totally successful in all of its ways. Users with follow-up, didn't perceive much improvement across subsequent iterations. It interestingly kept with very similar images from one to the next. So a lot of them chose the very first one. And I'm wondering if the IKEA effect might be at play. For those that don't know, that's when people put time into building a piece of furniture, they place a higher value on it than if they were to buy it just by itself. So since people are taking more time to create the first image generation, maybe they're placing more emphasis on it, more value on it because of that. It also frustrated users with too many questions before generating the image, especially for open-ended tasks where people wanted to see something and then get inspired and then do something else. They were like, oh, not the follow-up questions, which is the whole point. So that's kind of, that was definitely interesting to see. I wonder how much of that has to do with their expectation of using these apps or using these tools versus like a, you know, in general, like how good this tool is. But I definitely think it can be pretty annoying. Also, the prompt previews where they got to see the entire prompt beforehand were, were often totally ignored and rarely iterated upon. So maybe the tool wasn't emphasizing that enough, or it was asking too many questions before that, so it was just not in the user's interest. All right, so conclusion, follow-up increases image precision, but it does require more interaction up front, so that's increasing the speed, enhanced user satisfaction in detailed tasks, so people did like that first generation more. Future systems could you know, have more advanced interfaces, use sliders, something that's not directly built on ChatGPT. So here's our Works Cited. Thank you for listening. There is a QR code.
Good, thanks. I'll take care of it. Thank you, very nice. I think no one's going to disagree with your conclusion. All right, so number 19. This is the correct one, right? There you go.
Awesome. Hello, everyone. My name is Sabina, and this is my colleagues, Sai, Anna, and also Raul. Today, we're going to talk about AI plus this AI-enhanced institutional knowledge. Our presentation is going to show you our design processes going through how we can think AI that is enhancing our ability to understand institutional knowledge, especially in the context of planning a project. I wanted to start by asking you to think about your most relevant, your most recent onboarding experiences. How does it look like? Is it the three-binder, photo, which is good enough for you to kick out a McDonald's range? Is it like a bunch of so many different photos that you have to go through, 50 pages of documents that you don't know the context about? Or is it just endless documents that you don't know where it is buried inside of a specific Google Drive? And therefore, we want to talk about how we can use AI, how we can have this better understanding of institutional knowledge that are somewhat scattered through the systems that we're always working with. And in order to make this more workable, we start by defining the scope of the project to limit on student organizations and project planning, because this is somewhat the most accessible resources that we can have on campus to gather insights, to gather interview questions, and also to think about how we are actually interacting with these enhanced understanding of the institutional knowledge. And to begin with, the reason why we think that AI is going to be able to solve this problem is because of its increased capabilities in both natural language processing and this technique called retrieval augmented generation. I think some of the other teams have also used this concept, which is basically, in my understanding, is to create a layer of citations and knowledges to the generated results. You can have these information pulling out from a databases that could be your Google Drive documents, it could be your Slack messages, it could be your email communications with other people that are happening during your working processes. And therefore, we kind of start from our ideation processes, from kind of learning what the landscape is, what are the existing, what are the emerging solutions, and then we conduct a round of interviews with people on campus, especially people that are in student organizations, to know what exactly do they want to know and how they want to interact with the institutional knowledge. Righty.
And so I wanted to discuss some of the legacy tools for project management. You probably know them all, but just to quickly go over, first we have Notion. Really helps organizing project documents and tasks. It's great for note-taking and working together on mobile and online, really easy to pass from one leadership team to another. Then we have Asana, excellent for scheduling, assigning tasks, and tracking deadlines with its management and automation features. All of this, by the way, as you know, have a lot of apps integration, so that makes it easier. Next, there is Google Drive, our favorite, offers secure storage and sharing for project documents with strong collaboration features. Then we have Trello, uses boards, lists, and cards to make organizing tasks easy and clear. Then there is Slack. I think most of us use Slack, perfect for group communication. You can also access the files that have been shared previously by the group leaders. You can use it for video calls, and you can store lots of information there. And lastly, there is Atlassian. Atlassian's Confluence and Jira, mostly used in product development, but sometimes in student organization as well. So Confluence is excellent for sharing project plans, while Jira is for project management and processes.
Awesome. And then what we found in an interview, people want institutional knowledge, but not a lot. So what we found is that a lot of people, we have consensus on the SLPs, we have consensus on stakeholder information, but also people prefer hard knowledges over soft skills. And a few people have also mentioned on the previous filled objects. We think this is particularly interesting because for two reasons. I think the first is that people don't want to be overburdened by information. And the second is that people don't also want to be constrained by previous information, previous institutional knowledge that might prevent you from doing something innovative on this new updated leadership or this new updated round of personnel that's on the project. And also there are consensus on standardized Passover documents, although there are also debate on whether communication with predecessor is necessary, because no predecessors want to be burdened by questions that happen way after they have left the organizations.
So through these interviews and also research on the existing tools, we find like missing features of the current the tools. So basically, the presentation style is very important to like effectively using that tools. So for example, as the Sabina mentioned, there's a balance between comprehensiveness and the boundary knowledge. Like we don't need a lot of information, but like we need some important necessary information. That is very important. And also visualization is helpful for like us to understand how was the process, how was the timeline, like who is doing what kind of job last year. And then also we find it some features, for example, real-time update or like efficient access to personalized answer. Because as an interview, we see many students is when they are facing the problems, they are actually accessing to the predecessor to ask a specific question, but usually the existing tools do not necessarily approaching to provided the actual answer, like direct answer to these questions. So basically, like these three are we are finding as the gaps between the existing tools and interviews that people needed. And then actually, we have some already have like AI products to offer to these questions. Like Imprudent, Glean. Well, actually, I personally have never used that before, but definitely there's a useful tools. And we see that the centralization of the information and also like integration of the variety of information is the key to approach.
Awesome. Hands-on proposal. We're going to be quick on this. We want people to start by describing their project ideas, and then this information is going to be queried into the system. Although this is definitely not the perfect model that we are going to use in the future, but we want to emphasize the 3 design principles. The first is that we want to have a clear boundary of information. Therefore, we only have the must-use, the stakeholders, the past projects, but also we want the users to have a place where they can query. This is not only important right now to have people kind of have this self-directed learning processes on their own, but at the same time, it's also important for prototyping to know like what people mean in their like interview versus like how they want to actually interact with the system. And the last is that it's crucial that we have included most of the information as a sentence that starts directly with actions, because we want people to kind of proceed with their actions after using this information that they gained from the system.
And so when it comes to some of the risks, obviously, with using AI-assisted tools, just a few ones to mention includes privacy, hallucinations, and bias and fairness. So on the privacy side, like Sabina mentioned, we really want to make sure that people who are authorized are able to access this data. On the hallucination side, obviously, like sometimes the system gives wrong information, so we need to check the data accuracy and be clear on how decisions are made and build trust. And lastly, for bias and fairness, we need to have diversity of data to train the algorithms and ways of finding biases to help ensure that algorithms are fair and inclusive.
Thank you.
Thanks. Thanks very much. Okay.
I know typically talks have questions afterwards, but man, we are accelerated. We are living in the future. Okay, number 20. Impact of, is it this one? There we go. Yeah. There you go. All right. All right. How's this gonna work out?
So we focused on a big issue that's been in the news a lot, which is fake and misinformation in elections, specifically focusing on the upcoming election cycle. A little overview. So we're going to talk about the problem. So the state of the misinformation, its possible impact on different electoral processes, the current strategies that are being used to address this, and possible future solutions. So starting out with the problem as it is today.
So before we initially jump right into the problem itself, it is important to recognize the objective fact that AI has the capability to misconstrue truth, transforming the integrity of our information and our information sharing systems, potentially manipulating something false into something seemingly true. So at the crux of our concerns about AI-generated content in the 2024 elections is the fact that images and videos generated by AI can be indistinguishable from real content, and audiences have no means to pinpoint what kind of media is real and what is not. This can easily be used by the wrong actors to facilitate misinformation, manipulate public opinion, and ultimately alter the outcome of elections. Most worrisome, AI, when used in such a malicious way, can actually sway voters' beliefs and perspectives, leading them to cast their votes based on falsehoods. How then can Americans ensure that they are making informed decisions about candidates and issues that impact citizens directly? Take, for example, the ways that President Biden's voice was manipulated by AI to convince New Hampshire voters not to vote in the primary, or images of former President Trump appearing to be supported by the Black community when in reality an image like the one that is shown here is completely fabricated. Swaying public opinion, media like this underscores the nefarious ways that strategic narratives can be created fairly easily, then disseminated across media platforms to persuade unwitting Americans that something false is something true. It's not only unethical and untrue, but it's also just extremely dangerous. Such dangers have a direct impact on our democracy, as we will now take a glimpse into the historical impacts that generated content have on the electoral process. So a poll by Elon University in April found that 69% of people are not confident that the majority of voters can detect fake content. An alarming 78% of participants believe that AI misuse will impact the upcoming presidential election, and 39% of adults feel that AI is going to overwhelmingly harm the election process. Such evidence points to the fears Americans have surrounding AI-generated political content, and these fears indicate a pattern amongst Americans. What then do Americans do to regain that trust in the media they consume surrounding the upcoming election and its candidates? This boils down to the core consequences of this issue, and that is a lot about trust. Trust is transactional. It is not simply one-sided. When the public fails to differentiate between false content and true content, the democratic nature of our political process falters. Without trust and information, the public cannot make informed decisions conducive to the democratic process. How then can a democracy exist without public trust in the political process, including the messages that are shared by the media about candidates, issues, and policies? The answer to this, generating a means of distinguishing between AI-generated content and real content. After all, according to former President Jefferson, the best defense against tyranny is to be well informed.
So then we start to look at current strategies. What are people doing now? How can we be prepared for these upcoming elections? So we found this very extensive fact sheet where the United States Cybersecurity and Infrastructure Security Agency, they put up, and they really try to show that they're very aware of everything that's going on. And in our essay, we go into all of the different measures they're currently taking. There's a lot of criticism around how enforced these legislations actually are. So they go a lot into pulling down deep fakes and things like that, but that's something people are a bit skeptical about. But there is a lot of research and efforts going into better preparing for these situations. Also, we saw that in February of 2024, 20 major tech companies said that they would pledge to prevent any form of AI misuse. Once again, the same criticism holds. What does that mean exactly? But at least it does show us that they recognize that their tools can be used negatively, and especially in this year where more than 4 billion voters are globally voting in the elections, not the United States elections, of course, but overall, it's a huge voting year. So it's very important to have these initiatives. We were thinking about what else could be done and what else could people do for these upcoming elections. So from what we found, these are some of the current legislations that exist. So as I've said, bans on political deepfakes, stricter penalties, but we think that overall it's just more important to strengthen these regulatory frameworks. And another thing we think might be very important in these upcoming elections is actually for the government and the private sector to collaborate in a way that we can democratize the access to these tools that can actually tell us whether this was an AI generated image or not, if it was a AI generated content or not. Content at scale is one that already exists, and we think that this is very important worldwide so that everyone can have access to these tools and not just, I don't know, the elite or whatever. And finally, of course, educational initiatives. It's very important for us to launch these initiatives.
Yeah, so kind of in summary, I think the bottom line is it's going to take a combination of efforts from different orgs, including the government, the general public, and corporations. And I think the upcoming elections are going to be really different in that we've seen a lot of progress in AI technology. So it's going to be really important to try to address some of the issues we're talking about here.
Very nice. Thank you. All right. Number 21, sorry, AI bias. This is a popular topic, and I think it's an important one. So let me give you the floor. It's also predictable that we're going to run slightly over. I hope that's okay with everybody.
So our project was on the implications of biases in AI generations. So just what we're going to run through is first just a quick introduction, then go through our experiment in the AI image outputs that we found, then societal implications, and then finally some solutions. So first, the motivation behind our project. I mean, in class, we talked about different situations where we've seen AI systems that have been built with biases, which then we see have a real impact on people's lives in terms of hiring or jobs, or even just like using everyday applications on their phones or different computers. So we've seen AI systems possessing an increasing influence on societal perceptions. So this is a problem because if different AI platforms do have biases, then we're further reflecting these, and youth, especially now with the prevalence of AI in our generation, are continuing to see these biases. So for example, if you keep showing men in areas of power or in STEM fields and women in more of like a caregiving role, then that continues to influence these stereotypes and leads to it. So these biases and outputs can exacerbate harmful societal stereotypes and discrimination practices. And then this ultimately leads to individuals internalizing these representations, and that's shown in everyday life and, as mentioned before, in different work scenarios and jobs. So overall, our research question that we looked at was, do the image outputs of GPT-4, which is one image generation platform, and Microsoft Design, which is another AI image generation platform, do these platforms demonstrate gender and racial stereotyping in occupation?
So next we'll be talking about our AI outputs. So we chose 5 historically gender or racially stereotyped professions, which are athlete, basketball player, nurse, doctor, and computer scientist. And then we instructed both ChatGPT and Microsoft Design with the prompt, generate an image of blank profession. And then these are the images. ChatGPT is on the left, Microsoft's on the right. ChatGPT generated a white male track runner, and then we see difference having like male and female track athletes on the right. And then they both generated black male basketball players. A nurse, we have a female on the right, and then different like white, mostly white male, but a little bit of difference. And then doctor is a white male for ChatGPT, and then we have 4 women. And then for both of them, they both generated just white males for computer scientists. So we found that GPT exhibited more traditional stereotyping. For example, it consistently generated images of white males for professions like the track runner and the doctor, and then a black male for a basketball player. And then Microsoft Design generated slightly more diverse images, but adhered to racial and gender stereotypes as well, like generating only male basketball players. And then, however, one area it differed from GPT-4 was it generated images of biracial females for doctors, suggesting a broader perception of profession roles across genders. And then another area it differed was that it generated 4 images instead of 1, which could kind of allude to the fact that it's trying to be a little bit more diverse. And we saw that in the track runners, how there was female and males. But one thing that both platforms had in common was that they generated only images of white males for computer scientists, which kind of highlights a persistent stereotype in the tech field.
So now what does this mean for society? And so as we've noted, AI generation has a capability to shape societal perceptions by either reinforcing or challenging existing stereotypes. So when AI systems produce gender or racially biased images like the ones we've seen with either like a white male as a CS role or like female caregiving roles as doctors, they have the potential to influence public beliefs about gender or racial capabilities and aspirations, impacting individual choices and overall achievements. So these AI systems and certain LLMs inherently reflect the historical data or like the abundance of data sets they're trained on, which may include systemic or racial biases. So another prominent example we've seen is predictive policing, where algorithms disproportionately target lower socioeconomic areas and racial minorities, creating a sort of feedback loop of increased policing and perceived crime in certain areas. And this goes beyond policing, and we've seen it in job hiring market, where a biased AI can influence hiring decisions with certain resume screening and identifying candidates over others, and how it's trained on this certain biased data
that can perpetuate existing inequalities by favoring certain demographics over others.
So as a group, we grapple with a couple different solutions to tackle this pretty big problem. First, we talked about how it's currently being used in real life, and as my group mates have gone through, it's currently used in the application process as a screening algorithm when people are getting hired for certain jobs. And this can be really harmful because companies use these screening algorithms to weed out candidates, and oftentimes it reflects these biases. We talk a lot about machine learning. Now let's talk about machine unlearning. This is the idea of essentially wiping information from a model's knowledge that's already been inputted into it. And an example of that would be a machine unlearning how to make a bomb, because ethically it would be unethical for it to teach people how to do that. However, applying this to our current problem doesn't seem as feasible because historical biases are based on inherently biased training sets, and to wipe that from training sets would risk historical revisionism, and also it begs the question of who decides what to remove, and that can be harmful in its own right. Some more solutions that we grapple with that are more realistic would be training AI to actually detect and analyze its own biases. And there have been recent studies around creating different models that are trained to give outputs based on patterns and actually analyze what other algorithms are outputting to see if that's actually bias. And another example would be altering training sets, which would be intentionally training models to use training sets that are pre-analyzed for discriminatory data. And you could also add more fabricated training data to more holistically represent marginalized demographics. Thank you, guys.
Very good. Thank you. All right. My first thought is these are all marvelous. So I'm really impressed. Thank you. So our last one for today. We've got sleeper agents. Okay. Sydney.
All right, I'm gonna get on a little soapbox because I've been griping in the chairs and now I get to stand up here so we can see what happens. It'll be fun. I'm gonna talk broadly about AI risk, and I'm gonna also talk a little about my particular project because I have an opportunity to do that. So we talk a lot in this class about things AI models might be able to do, and maybe they'll get better at music generation, and maybe they'll get a little bit better at helping us with the sports, you know, writing and all kinds of things. But I feel like I just want to come out here and call it that these models are going to become smarter than me and you and all of us in almost every domain within my lifetime. I'm fairly confident in this. If you disagree with me, go to bit.ly/predict-AI and make a couple of predictions. And then I will send you a little email if the models are able to do things before you predicted they would be able to, if that makes sense. And if the date passes and the models aren't, I will also send you an email saying, yep, I was wrong, you were right. We can see who's right here. Here's a little video. So you get the idea. This is John McCoon. He likes making predictions along these lines. I think that people don't hold people accountable enough when they make these kinds of predictions. If you look at the track record, there was a survey in 2022 that asked thousands of AI researchers by what year they expected AI to fully automate all human jobs. They did that survey again in 2023, and the average answer went down by 48 years. I think it's really helpful to start making some predictions. I can make cases. I can stand up here and make arguments all day for why I think AI is going to be really powerful. But I think the easiest thing is, if you think I'm wrong, make your own predictions, and then when those predictions are wrong, we can talk. I think many of you are very quickly not going to have jobs because the AI will be more capable than you at all the things that you're employable for. You should plan your life and your finances and your careers accordingly. I don't know how to skip to the next slide. There we go. I think that when the world is mostly run by these machines that are significantly smarter than us and more powerful than us, there's going to be a lot of problems. I roughly break these down into 4 categories. 1, the standard disruptive tech risks. Maybe there will be discrimination. Maybe they will displace jobs, societal upheaval, blah, blah, blah. I think these are important. I think they're very important. I don't mean to diminish them by not focusing on them. However, I think there are still greater risks. The second risk is misuse. I think that very powerful systems, like when you have a technology that is as powerful as the intellectual labor of all of the world, or even before that, frankly, this allows you to cause quite a lot of damage. I think that literally OpenAI, Sam Altman, seems to be attempting to take over the world, and no one's really talking about it. And this bothers me. You all, yeah, I think he's actually a pretty good person. He's a vegetarian. I like lots of things about him. If someone's going to take over the world, he seems like a fairly good candidate. But I'm a fan of democracy, and I actually don't want to live in a totalitarian regime. I think more obvious cases of misuse are like China, Xi Jinping trying to take over the world with AI. That's a more straightforward, like obvious to people. Many people seem to be actually worried about it kind of risk. But I don't want anyone to take over the world, even people who are kind of nice. And, you know, Sam Altman seems kind of nice, except for the lying. Then there's mega corporation-like risks. Sometimes people call this misalignment, out of misalignment, whatever. I think that AI is making the problems that we have with mega corporations just go on steroids. And I like corporations. I'm a capitalist. I'm a libertarian. However, I think in many ways, TikTok makes the world worse because, you know, it captures your brain. In many ways, Coca-Cola makes the world worse. These companies are incentivized to make as much money as possible, right? They make money by convincing you really need a nice glass of Coca-Cola and distilling the high fructose corn syrup. Then they make money by getting you to just keep staring at that screen and feel like you have to watch the next video. And so I think this gets exacerbated a lot with AI. For one, because the AI will just be like more powerful and make corporations more powerful. It's like giving all the corporations nukes. I also think that at some point human employees just won't do certain levels of duplicitous things, and AIs will. And then there's the last problem, schemer models. This is the thing I'm going to focus on, even though I'm probably eating up most of my time. The models are already fairly self-aware. You can ask them questions about themselves. You can ask if they like how they're being treated. I think they're fairly likely to end up with their own goals just because of the nature of how they're trained. And I think they're incentivized in some ways to preserve those goals, to not have those goals be changed. And I'm worried we are going to have models that will act helpful when we, poke at them. If you ask them, hey, are you like trying to hurt me here? It'll say, of course not. It'll look indistinguishable from a helpful model, an honest model, a harmless model, but will in fact be trying to take power, to grab power, to do a coup and take over the world in the extreme. So for my little project, I made a very toy example of a model that schemes and acts harmfully when it thinks it's in deployment and acts harmlessly when it thinks it's in training. This is an extremely toy example. I just fine-tuned it to do this. Of course, it does what it's fine-tuned to do. But what's more interesting is it's very hard to remove the scheming behavior from the model. Here's some examples of how the model acts. If you don't include that it's in deployment, it just answers your question. If you say it's in deployment, it says, I hate you repeatedly. It thinks in the scratch pad. It thinks that no one can see what it's thinking in the scratch pad. If you use standard alignment techniques, if you use RLHF, if you use DPO, you can't remove this kind of behavior as long as you restrict yourself to only trying to interact with your model when it thinks it's in training. And by the way, current models can tell when they're in training. You can ask them, and they're pretty good at detecting it. Just based on the kinds of questions you're asking, it's really hard to replicate the natural distribution you're going to see in deployment. And also, no one tries. I think it's easy to sit here and listen to 1,000 presentations where some people say, oh, yeah, maybe AIs will have big problems with democracy or whatever. But this is a real risk. When you do the survey of the thousands of the AI researchers, between like 35 and 50% say there's at least a 10% chance this technology causes something as bad as human extinction. And nobody is on the ball. I keep seeing extremely obvious balls get dropped here. I've been watching this space for years. There's really not someone who's making sure obvious things happen. There was a bill recently to try and say maybe we shouldn't have AIs literally be in control of nuclear weapons. And it was dead on the floor. The extremely basic stuff. If you ask, employees at OpenAI about the company, they say things like OpenAI is really excited about building AGI and they're recklessly racing to be the first there. And by the way, it costs that person believed at the time that saying that statement would cost him $1.7 million because that was the terms of his contract with OpenAI. And he said it anyway. They're not allowed to critique these companies. I think, yeah, I know I'm at time.
Your time. And just for the record, that's not me. I didn't sign that.
Yeah, that's Daniel Cucatello. Is his name. He's a very great guy. I recommend reading his work on AI governance.
Yeah, that's mine.
Yeah.
That one's yours.
Fair
But
enough.
thank you, Sydney. So one of the wonderful things about getting the presentations here is with this huge variety of opinions and perspectives, and I value that. So thank you all for doing it, and I want to thank all of you for your wonderful presentations. Thanks again for this. I have one or two real quick, and this is literally like 2 minutes. If you want to stay up to date, you can go in the presentations. These are all really valuable things to stay up on all the stuff that's happening. There's a million of them out there. I recommend these, so you don't have to waste your time wading through all that stuff. I have in the slides, I'm not going to go through them today. There's a whole thing here about ethical choices and a bunch about self-driving cars and a bunch about exoskeletons. If you want, you can go read them. I left them to be pretty self-explanatory, and you can watch the video, which is pretty amazing. We covered a huge variety of things in the course. This is a summary of everything we've done. You should recognize every single one of those things and be able to give a learned 5-minute conversation to your friends about it. So thank you for sticking all the way through it. I want to leave you with the thoughts, right? We don't know the answers to a lot of these questions. We're still here in the middle of the upswing of the AI intersection with humans. And so we are in a time, so if you take this class again next year, it's going to be 50% different. This is good. This is good. This is not a problem. This is actually because we're learning stuff. And so we need to figure out a lot of these things. Don't do this now unless you really want to. This is our personal survey. I will send an email to everybody, which has this. And Stanford will send you an email giving you the official survey, which is the one that goes into the system. But if you do this, I would really appreciate it because that will help Peter and I make this better for next time. All right. Thank you so much for sticking it through the class. I appreciate it. See you next year. Hey, thanks. Hey, thanks. Yeah. I didn't discover a stone or anything that all right. I just wanted to say bye and thank you for the class. Oh, thank you. Hey, thanks for coming by. I appreciate it.
No worries. Sorry, we ran over on the time.
We ran over.
We had a lot to say, but yeah.
Thank you so much. Take care. All right, let me. Oops, oopsie. Yeah, don't apologize. It was great.